Hi, and welcome to video 2 of 3 videos for section 10.1. So as I alluded to in video 1, we're still solving systems of linear equations in 2 variables, but sometimes the equations aren't given to us in a nice, orderly manner where we can just solve for one variable and use substitution. So that's when we have to look at the possibility of option 2, which is known as the elimination method. So the steps for this are as follows. We're going to manipulate the equations so one pair of variables, so either the x variables or the y variables, have opposite coefficients. So, what I want to get is, for instance, maybe one equation has 2x, the other equation has minus 2x. Or maybe one equation has 5y, the other equation has minus 5y. I want to multiply both one or both equations by some value so that I create this opposite coefficients between one of the pairs of variables. Once I do that, I add the equations. So add the x variables down, add the y variables down, add the constants on the right-hand side down. Once I do that, because one of the pairs of coefficients is opposite, those are going to cancel out. So if I have plus 2x and minus 2x, when I add them, the x variable is gone, and all I have left is the y variable. So once I add the equations, I'm going to solve, and then as before, I'm going to back substitute. So once I get one variable, solve it, use it in the other one of the equations to get the remaining variable. So let's say an example here. Let's say we have 4x minus 3y equals 11, and 8x plus 4y is equal to 12. So, we want to manipulate these so that either the x variables are opposite or the y variables are opposite. There is no rhyme or reason why you choose one or the other. It's strictly a preference. So the y terms already have a plus and minus sign, so we could multiply this one by 4 and get a negative 12. We can multiply this one by 3 and get a positive 12. Then they would cancel out. Another option is what? We have the x's. One is 4x, one is 8x. So if I just multiply the first row by negative 2, what happens? I get negative 8x, and I don't have to do anything with the second row. And again, you can either eliminate the x's or eliminate the y's. It doesn't matter. You'll still get the same answer. So if I multiply the whole first row by negative 2, I get minus 8x. Negative 3 times negative 2 is plus 6y. Be careful with your signs. And negative 2 times 11 is negative 22. And again, I'm not going to multiply the second row by anything. I already have 8x. That's what I wanted. So I'm just going to leave that row as it was. So I've manipulated the equations, or at least one of them. Now I'm going to add straight down. Negative 8x plus 8x is 0. It's gone. 6y plus 4y is 10y. And negative 22 plus 12 is negative 10. Again, the biggest thing with solving these, be careful with your signs. So divide everything by 10. So I get y is equal to negative 1. So now I have to back substitute, and in this case, go back to your original equations. Just in case you mess something up when you were multiplying the rows, if you plug it back in now, that's when it'll tell you, wait, something's off here. You can choose either equation. I'll just choose equation 1. So if I do that, I get what? I get 4x minus 3 times y, which is a negative 1, has to equal 11. So 4x, negative 3 times negative 1 is plus 3. is equal to 11. Subtract 3 from both sides, you get 4x is equal to 8. And divide by 4 gives you x equals 2. And again, you can check your answer if you want. Plug it into the other equation. 8 times 2 is 16. 4 times -1 is -4. 16 minus 4 is 12. So you can be 100% sure when you turn in that exam, you have the right answer because it worked. The numbers worked in your equation. So that's it. Another quick little video showing option 2, the elimination method. Again, the key is just getting a pair of the coefficients to have a pair of variables to have opposite coefficients. Once we do that, add down, solve for our variable, back substitute. So come on back, we'll look at video 3, a couple of special cases where maybe we don't get numbers, specific numbers for answer. We either get no solution or an infinite number of solutions. So that'll be in video 3. Come on back and we'll look at those cases.